So we've looked at Lewis structures for ionic compounds. Let's look at covalent bonding. For molecular compounds which have covalent bonds, we show these as neighboring atoms which are sharing electrons in order to obtain octets. And for the little guys, we say a duet is good enough. So let's look at the Lewis structure for water. So water is going to have oxygen and hydrogen. And how many valence electrons does hydrogen have? One. So there's the Lewis structure or Lewis symbol for hydrogens, the two of them. And how many valence electrons does oxygen have? 6. So are these guys happy by themselves? Happy being defined as either having an octet or a duet? No, they're not. This hydrogen is trying to get 2 electrons. And so he's talking to the oxygen saying, hey, give me one of your electrons. And the oxygen says, no way, I've got 6, but I need 8, give me your electron. And the hydrogen's like, no, I'm not going to do it. And they're arguing. And then they realize, hey, what if we shared? What if we shared this pair of electrons? That's a covalent bond. I'm going to do that again with the skinny line so we can still see the electrons. So they share the electrons. And the hydrogen over here says, hey, you're sharing with him, you need to share with me too. And the oxygen says, well, yeah, that works for me because I've got this other odd electron over here. I don't know why that one's crooked. It's better. So now they're sharing. And when they share, they count them as the shared electrons as belonging to them. And so hydrogen looks at the situation and says, I've got 2 electrons. Look at me. Aren't I cool? And this one does the same thing. It says these shared electrons belong to me. And the oxygen counts all of those electrons as well. And so the oxygen has 2, 4, 6, 8 electrons. And so, because what do you do when there's not enough pie or there's not enough cookies? You have to share, right? And then everybody gets some. You're like, well, how can electrons count for both? Well, there's Kirk, and there's Jody, and between us, we have 6 children. And if you ask Kirk how many children he has, that's my husband, he'll say, I have 6 children. And if you ask me how many children I have, I'll say I have 6 children. Because they're all mine, and they're all his. Are there 12 children in the house? Thankfully not. 6 is enough, right? Some people would say 6 is more than enough. But how do you choose which one to give back? It's hard. So the shared electrons count for both, okay? So here, oxygen gets an octet by sharing 2 electrons, one with this hydrogen and one with the other hydrogen. And the hydrogen gets a duet, which is all it can handle, by sharing its 1 electron with the oxygen. So by sharing, we satisfy the octet rule. Okay, so let's look at chlorine and what happens with chlorine. This is one of those diatomic elements. So there's 1 chlorine atom. There's another chlorine atom. How many valence electrons does chlorine have? 7. 1, 2, 3, 4, 5, 6, 7. And this chlorine has 1, 2, 3, 4, 5, 6, 7. Now there's no way 1 chlorine is going to give up an electron and give it to the other. It's not going to happen. Nonmetals form anions. They don't form cations. But do you see how they could both have an octet? if they each share one electron with the other, this chlorine now has an octet, and this chlorine has an octet. Covalent bond. Now, there's different kinds of electrons in here. There are bonding pairs, and there are what are called lone pairs. And I should have erased the circles. I can get rid of those circles. I can't get rid of the others. Let's use, I don't know, purple. So these are bonding pairs. They're involved in a bond. They're being shared. And over here, it's going to get very colorful. Those are bonding pairs. So the bonding pairs are circled in purple. The pairs that are not involved in bonding are lone pairs. They're just there, but they're not being shared. So they're lone pairs. So everything else is lone pairs. I don't know, let's make them all green. So these are lone pairs. There's a lone pair there, and this is a lone pair, and a lone pair, lone pair, lone pair, lone pair. Lone pair, lone pair. So we need to be able to identify lone pairs and bonding pairs. Sometimes we show the bonding pairs as just two dots between the element symbols, and sometimes we show it as a single line. And I've kind of done a hybrid here. So when you see the line, remember that a line, a bond, is two electrons. It's like you connected the dots. Any questions? Two atoms can share more than one electron pair. So let's look at oxygen. So here's oxygen. It's O2, there's two O's. So how many valence electrons does oxygen have? 6, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These form a molecule, and they're going to do that by sharing. Well, if they share that pair of electrons, do they each have an octet? No. They each have 7. They're getting closer, but it's not 8. So then, if you don't have enough, you have to share more. So they're also going to share that guy down there, that pair. Okay, so that looks weird. Actually, it looks like kind of a strange smiley face. That's just showing you how did it happen. So if we were going to draw this a little nicer, we might draw it like this. This is called a double bond because we've got 2 electrons being shared. I'll take up some space over here. Another way is to show that as 2 lines. And each of these lines is like these dots connected. So this is a perfectly good Lewis structure, and this is a perfectly good Lewis structure. How many lone pairs are in the structure? 4. This oxygen has 1, 2 lone pairs. This oxygen has 2 lone pairs. How many bonding pairs? 2. Question?
I thought when we drew the Lewis structure that we had to show everything around.
You'll see both, and if I care about it, I'll be specific in the instructions.
Okay.
A Lewis structure will show lone pairs. You should show the lone pairs. The difference here is whether we're showing the covalent bonds as lines or dots. The lines are actually a lot easier to look at and to see what's going on. But sometimes they want you to show those as dots, and there's advantages and disadvantages both ways. Any other questions? So that's a double bond. A single bond is sharing a single pair of electrons. A double bond is sharing a double pair, two pairs of electrons. And so let's look at nitrogen. I think nitrogen is going to be green. So here's nitrogen and nitrogen. How many valence electrons? Somebody. 5. Thank you. 1, 2, 3, 4, 5. And this one has 5. I am drawing them in an orientation that suits my purposes, but you can draw them however you want. So how could just these two guys get together and have octets? Triple bond. So they're going to share 3 pairs of electrons. So that might look like this, or it might look like this. So triple bond sharing 3 pairs. Any questions? So does our model of covalent bonding explain reality? Well, if we look at H2O and H3O, H2O is stable, H3O is unstable. So let me just draw those for you real quick. I'll throw them up here. So here's H2O, and here's H3O. One, two, three, four, 5, 6. This follows the octet rule. Oxygen has 8. The 2 lone pairs, the 2 bonding pairs, the hydrogens each have a duet. This does not follow the octet rule. Here, oxygen, oops, I like the green, but I want the arrow. Okay. Here, oxygen has 9 electrons. It's too many. So that's not stable. What about H3O plus, the hydronium ion, and H2O2, hydrogen peroxide? Well, let's get my things correct here. H3O plus would be like this. So H3O wasn't good. The number of electrons shown in our Lewis structure has to be equal to the total number of valence electrons that all of our things have. And so each hydrogen has 1 valence electron, so that's 3. And oxygen has 6, right? So 3 and 6 is 9. And so here we've got 2, 4, 6, 7, 8, 9. So we had to show all 9 of them. In H3O plus, the plus charge means that we lost an electron. So that 9th electron on oxygen that was messing things up is taken off, and now this is a perfectly good Lewis structure. All 3 hydrogens have a duet, and the oxygen has an octet. H3O plus is stable. Then there's H2O2. See if we can draw a decent structure for that. So there's hydrogen peroxide. Does that fulfill the octet rule? We look at oxygen. Does this oxygen have 8 electrons around it? Remember that a line is 2 electrons. Yes. And does this oxygen have 8? Yes. And does each hydrogen have 2? Yes, so we're good. So our Lewis model predicts the stability of these molecules and ions. Now, covalent bonds are highly directional. Ionic bonds are between the ions, but you're going to have attractions on multiple sides. And covalent bonds are just between 2 atoms. And so we observe that covalent bonds contain discrete molecules. And the forces that hold these molecules together are very weak. And so this Lewis model explains the lower melting points of covalent compounds. There are some covalent compounds with high melting points, but most of them are lower than ionic compounds. I mean, water has a melting point of 0 degrees Celsius. Sodium chloride is up around, I don't know, 1,300 degrees Celsius or something. It's really, really high.